Welcome back, IB Pre-Cal. So this is a fun lesson. We're going to be talking about evaluating trig functions for any angle, right? So you've done some application, you've reviewed acute angles, right? Reviewed acute angles. So now we're going to be talking about for any angle. So hopefully you remember the circular function. So we did this at the end of last spring. And hopefully you have some recollection of the unit circle, right? And how you want to know some of those values and how we're really going to be using them. So we're going to review a lot of the unit circle throughout this lesson to evaluate, the 6 circular functions, right? Sine, cosine, tangent, secant, cosecant, cotangent. I don't think I said that one yet. I wasn't writing it down. So we're going to be doing a lot of review with that in this lesson right now. So hopefully you've got something to write on and you are ready to follow along. So angles in standard position. We measure angles starting from the positive x-axis, right? And we just did some applications where we talked about bearings and we talked about how that was a little bit counterintuitive. So this goes back to your understanding of you're going to be starting from that positive x-axis, and we consider counterclockwise to be a positive rotation, a positive angle, right? Because we have positive and negative angles. So we're starting this, that is what we refer to as our initial side on the positive x-axis, and then wherever the angle ends is our terminal angle, and knowing which way I went. We also have what we refer to as coterminal angles, angles that have the same initial side and the same terminal side, but they have a different measure, right? So for instance, this might be 100, let's go with degrees. This might be 120 degrees. Well, I could start here, start in the same initial side, but go around this and end there. I have the same initial and terminal angle, or terminal side, sorry, but it's a different degree, right? This is 120 plus 360 degrees. Right? What is that? 480 degrees. Those are coterminal angles. I also could have potentially gone clockwise. Ooh, I don't like that color one bit. It wasn't what I thought it was going to be. Right, so I could have gone, I think this is going to be better, yeah. This way, right? That's going to be, really I'm doing 120 minus 360. I'm going the other way around. And I'm finding the other part of that angle, which would end up being, what is that, negative 240? Negative 240 degrees. Those would also be coterminal, right? So I can get a number of different coterminal angles that have the same initial side and the same terminal side, but they're a different angle measure. Find positive and negative angles that are coterminal with these. So this would be a really good place if you wanted to pause the video and try this on your own. Right, and hey, I could go 335 plus 360 gives me what? 395 degrees would be one. I could do 35 minus 360, and that's going to give me negative 325. Yeah, I hope my math is right. Yeah, right? So I have a positive and negative. I can keep going with that, but that's going to be right away what I would get. For beta over here, so I've got negative 150. Well, to get a positive coterminal angle, I'll go ahead and add 360, and that's going to give me 210. Yeah. If I want to find a coterminal angle that's negative, I'm going to go ahead and subtract 360 degrees, which would mean that I have negative 510 degrees. Right, 360 and 150, 460, 510. Good, negative 510. Here, well, I have 2 pi over 3. So here I'm dealing with radians, right? So it's the same process, but I want to look at, remember, 2 pi radians is equivalent to 360 degrees. So I would maybe want to say 2 pi over 3 plus 2 pi, right? Or plus 2 pi is the same thing as 6 pi over 3. So that's going to give me 8 pi over 3. That would be a positive coterminal angle. I could also do 2 pi over 3 minus 2 pi, or minus 6 pi over 3, which would give me negative 4 pi over 3. Right? And think about, like, where is that? 2 pi over 3. Right? That's 2/3 of a semicircle. I'm going to end up like over here. So, if this is my initial side and this is my terminal side, this is 2 pi over 3. This is negative 4 pi over 3. Pretty cool. So trig functions of any angle. Our geometry definitions only worked for acute angles, right? Angles that fit inside of a right triangle, right? In geometry, you learned right triangle trig. That was what we reviewed. What about if you have like a larger theta, right? Because we could really have this for any angle. So we are looking at that point. And we want to figure out, maybe this looks familiar, Pythagorean theorem, distance formula, Pythagorean theorem. I'm unconvinced I spelled that right. So we're really, and this I hope rings a bell a little bit, this right here, your R, is the radius of the circle. What circle am I talking about? Well, I have a circle here. Oh, that's really bad. Right? Oh my goodness. I was going to say I've gotten pretty good at drawing circles. Clearly not. So I'm dealing with the radius of this circle. That R, X and Y are a point that's on my circle. To figure out the radius, I'm doing the square root of X squared plus Y squared. The radius is going to be the same regardless. So if I want to know what the sine of this angle is, here's theta, I have to do Y, my Y value over the radius to figure out the cosine, right? So I really have, I feel like I need to go back and erase this, but I can't because I have like an old version of PowerPoint or something. So this is theta, but I have this like, remember reference angles? Hopefully, I have a reference angle right here. And if I'm going to find the sine of this angle, its opposite, that's the height, that's this Y value. That's how far up I'm going. Think about it as a graph over the radius. So this is theta, but I'm going to use the terminal angle to support this. To figure out the cosine, I'm going to use the X value. Well, if you're in quadrant 2, my X is going to be negative, right? So it's going to work out in that way. Whereas if I were to just go and look at just this acute angle, it's always going to end up in the first quadrant. And that's what we looked at in the last lesson and last time we saw you guys. So really paying attention to like, what is my actual X and Y value to figure out what's sine, cosine, tangent. So sine is going to be Y over R, cosine is going to be X over R, and tangent is going to be Y over X. Right, and then that allows us to then find the reciprocal. Trig function. So cosecant is going to be the radius over Y. The cosecant is going to be the radius over X, and cotangent would be X over Y. And that would work in any quadrant, right? So you have to remember that theta is coming from that initial ray. Like that is where I'm always starting and going around the circle. Remember the reference triangle? Notice theta isn't in this triangle. It's just used to help you remember the definition. These are new generalization definitions that are similar, and they're like stemming from what you guys learned in geometry and what we did in AAF. But you like use that idea of the reference angle, use the acute angles to help. Like think, what is my reference angle, and then which quadrant is it in? Would my y value be positive or negative? Is sine going to be positive or negative? Maybe you have some memory of what we did with this. So if that point, can I just clear my annotations? Apparently not. How do I clear my annotations? There you go. So if that point right here is negative 5, 3, well, to figure out the radius, let's show that piece of it first. I've got negative 5 squared plus 3 squared. I'm dealing with the square root of 25 and 9 is 34. All right, so that's r. That's my radius. So y, my sine of theta, is going to be 3 over the square root of 34. Therefore, my cosecant of theta is going to be root 34 over 3. My cosine is going to be negative 5 over root 34. It's going to be negative. And therefore, the secant of theta is going to be the square root of 34 over negative 5. And finally, the tangent of theta, well, I guess not finally, is going to be negative, I forgot my point, 3/5. And so my cotangent is going to be negative 5/3. So what happens when we're dealing with boundary arcs or boundary angles, right? So maybe that rings a bell. Boundary is referring to when it falls on the positive x-axis or the negative x-axis or the positive y-axis or the negative y-axis. Those are our boundary angles. So what happens with this, right? Do these definitions work for boundary arcs and angles? So if I have the point 0, 3 up here, the sine, well, I mean, if I go to find the radius, I mean, you can think logically through this, but 0 squared plus 3 squared, I'm just going to end up with the square root of 9, which is just 3, right? Like, it's the distance from the center. It's 3. It's on the boundary. I don't need to necessarily do that math. So the sine of theta would be 3 over 3, which is 1. Well, does that make sense? What's this degree? 90 degrees, or pi over 2 radians. Well, maybe you remember what the sine of 90 degrees is, or the sine of pi over 2 radians. Wasn't that 1? Doesn't that make sense? Therefore, the cosecant would also be 1. What about the cosine? When I go to do the cosine of theta, I get 0 over 3, which is just 0. Well, what's the cosine of 90 degrees? Or what's the cosine of pi over 2? Maybe we remember some of these nice special angles. Well, that's 0. Right? Remember that? What about, I lost my train of thought. This one, the secant. When you do the secant of theta, I end up with 3 over 0, which means that it is undefined. Right. Finally, the tangent of theta when we're dealing with this. So it's y over x. So I end up with 3 over 0, which is undefined. Right? The tangent of 90 degrees, or the tangent of pi over 2, is undefined. The cotangent would be 0 over 3, which is 0. If we were dealing with it with negative 5 over 0, think about where that falls. I need a new color and to clear this. Just tell you guys what I'm doing. I liked this one. If I'm dealing with negative 5 over 0, negative 5 over 0. Negative 5, 0, that's like over here, right? So that's on this boundary. That's 180 degrees, or pi radians. Maybe you have a recollection of some of this stuff about the trig functions. The sine is going to be 0 over 5, right? That's my radius, is 5, which is 0. Well, what's the sine of 180 degrees, or the sine of pi? Well, it was 0. Therefore, the cosecant is going to be 5 over 0, which would be undefined. The cosine of theta, x over r, would be negative 5 over 5, which is negative 1. Well, what was the cosine of 180, or the cosine of pi? It's negative 1. The secant of theta, the reciprocal of that, is just negative 1. And my last two, the tangent of theta, y over x, 0 over negative 5, is just 0. Well, what was the tangent of 180, or the tangent of pi radians? Those were 0. The cotangent would be negative 5 over 0, which is undefined. Hopefully this is bringing back some memories of things we did in geometry and what we did in the spring. The unit circle, right? That's really where we're going with this. Consider the special cases and definitions of the circular trig functions where r equals 1. Right? That's what the unit circle is. xy is a point on the unit circle with a radius of 1. That's why it is the unit circle. There's our very nice unit circle. The sine of theta is just y. Why is it just y? Because the radius is 1. It's over 1. It's over 1. Right? That's why it's working this way. The cosecant is the reciprocal. The secant is the reciprocal. The cotangent is the reciprocal, right? Reciprocal functions. We worked with those last year. So the coordinates of any point on the unit circle, x, y, x is the cosine of theta, sine is the sine of theta is the y value, right? This is x, this is y when you're looking at a point on the unit circle, right? If it's not the unit circle, I mean, it's really x over r and y over r is what cosine and sine are, right? That's the same idea though. If we take a look at, oh, is it going to let me click it? Oh, no. Oh, no, but you guys aren't going to be able to see my screen. Can I change how I'm sharing it? I don't know if you guys are able to see this, so I don't know how much I want to play around with it right now. But you guys have this PowerPoint, so you can go click on that applet and play around with it. Okay, so here is the filled out unit circle that we spent a lot of time last year looking at, a lot of time in the spring, and you guys filled this out and we figured out what each part was, and you probably have some experience with it through geometry as well, right? So these were the special angles that we dealt with, and we really said if you know quadrant 1, you know all the quadrants, right? And then just thinking through, oh, this is cosine, this is sine, right? And if I know it for 30 degrees and pi over 6, then I know it for 150 because its reference angle, its reference angle is just 30 degrees, right? So you just need to remember that, well, my x, it becomes negative cosine, positive sine. This becomes negative cosine, negative sine, and this becomes cosine, negative sine is an important piece to remember. Maybe you remember all students take calculus. That tells you what is positive in each quadrant. Everything's positive here. Just sine is positive. Just tangent is positive. Just cosine is positive. Right? So maybe you need to go back and practice some of these. Refresh your memory so you're speedy with it. How do you remember where the angles are? Right? So you've got the ones that are cutting it up into sixths. That's hard to say. Pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. We also have the quarters. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. This is a 1/4 of a semicircle. This is 3/4 of a semicircle. This is 5/4 of a semicircle. That's more than a semicircle. This is 7/4 of a semicircle. And we've also got the thirds. This is a third, 2/3, 4/3, and 5/3. Or you can think about it like this is 1/6. This is 2/6. Oh, that's a third. This is 3/6. Oh, that's a half. This is 4/6. Oh, that's 2 pi over 3. This is 5/6. 6/6. Oh, that's pi. 7/6. 8/6. 9. Right? You can cut the whole thing into sixths as well, because that works with thirds. How do you remember the signs? I just talked about this. All students take calculus. Remembering what is in each quadrant. If you know quadrant 1, you know them all. So we don't want to rely on our unit circle. It's really good to practice filling out the unit circle and knowing these. We want to know them pretty quickly. So I'm going to actually take the unit circle away. What I would suggest you do is pause the video and go through these. And can you do them without a calculator, certainly, but without even looking at the unit circle and thinking through it, and maybe even time yourself so you get an understanding of that. So let's see. Hopefully you pause the video, or you're about to pause the video and try it before I go over it. Sine of 2 pi over 3. Think about which quadrant that's in. 2/3, 2 pi over 3. That's going to be in quadrant 2. So my sine will be positive, right? So I'm going to be dealing with positive √3/2. 3 pi over 4. That's going to be in quadrant 2. So my tangent is going to be negative, right? That's the quarters. I'm going to end up with -1 there. At any fourth, it's like 45 degrees. The sine x and y are going to be the same. 11 pi over 6. That's almost a full circle. It's 1/6 left. So that's going to be in quadrant 4, where my cosine will be positive, right? So that's going to give me √3/2. I think more in radians than I do in degrees. 240 degrees, that's going to be 60 degrees past a semicircle, right? So that's going to be, my reference angle would be 60 degrees. I'm going to think about it, what cosine is here, what the cosine of 240 is, and then I'll flip it. The cosine, so that would be in quadrant 3, where cosine is going to be negative, so my secant will be negative. If it's dealing with a 60 degree, it's going to be 1/2, so I'm going to end up with -2. The cosine of 90, well, that's a boundary angle. I know that one, it's 0. Cotangent of -5 pi over 6. So here I'm going clockwise, right? I'm actually not quite at a semicircle. -5 pi over 6 and 11 pi over 6 are the same thing, right? Here, I'm going to think about tangent of -5 pi over 6. So I'm dealing with sixths. Sorry. So that's if it's in this is going to be in quadrant 3. And in quadrant 3, tangent is positive. So that's great. I'm going to be dealing with something that's positive. 5 pi over 6, I'm thinking about sine over cosine. So I'm going to be dealing with 1/2 over √3/2, which is going to give me 1 over √3. Therefore, the cotangent is just going to be √3. And finally, cosecant of 7 pi over 3. So like I'm really thinking through it now. You want to get like, I'm explaining what I'm thinking, but you want to get like, you got to practice. Really, this just takes practice, right? So the sine of 7 pi over 3 is what I'm going to think about, and then I'll do the reciprocal of it. So I'm dealing with thirds. So just think about what's the sine of pi over 3. Oh, the sine of pi over 3 is √3/2. And that's going to be 7 pi over 3 is going to be, that's actually coterminal, isn't it, to pi over 3? So that's actually just going to be in quadrant 1. So it's going to be positive. Ooh, that's not a number sign, that's a positive sign. So what did I just say, √3/2? So I'm going to get 2 over √3. Or if you want to say 2 root 3 over 3, that's fine. Hopefully I didn't make any errors in that. This might remind you of something that we did a little bit in the spring. I attempted to simulate for you guys, but I said I was really sad you didn't get an opportunity to do it. Speed trig quizzes, right? So again, we're gonna try to simulate this, but since we've got you in class and it's not like you can't just attend office hours like the spring, we're gonna get these in class because it does really, you do want to know. I mean, the purpose of it is that you want to know these functions and these values really quickly, because it's not necessarily do you know what the cotangent of negative 5 pi over 6 is, but you want to be fluent with that so that when you're being asked to apply it, whether it's this year or in future years, that you're not stumbling over, well, what was that trig value? You're able to just come up with it, and it's not a stumbling block when you're working with other more rigorous math and you're applying it into other things. So I'm going to do a few of these with you guys, and then we'll finish them later. So here again, and we haven't picked up a calculator for anything, let's go ahead and let's do A, let's do B, and let's do C, and we'll stop there. So the cosine of pi over 6 is root 3 over 2. I got it. I clicked too many buttons. A, B, C. Let's try that again. Cosine of pi over 6 is root 3 over 2. The tangent of 5 pi over 3. So that is going to be a little, that's quadrant 4, right? That's like, if you think about the circle, it's down here, right? So my sine, I've got root 3 over 2 divided by 1/2. So it's root 3. It's going to be negative. So I end up with negative 3/2 for this. I think I did that correctly. The sine of 300 times the cosine of 300. This is interesting. Think about where 300 is, right? This is 360, so it's going to be 60 degrees less. It's the same exact angle, right? So the sine is going to be root 3 over 2, but it's going to be negative. And the cosine is going to be positive 1/2. So you're going to end up with negative root 3 over 4. And finally, the cosine of 180 degrees, it's going to be negative 1. And the sine is going to be 0. So it doesn't even matter what the sine of 45 is. I don't need to worry about that one. And then the cosine of 145, what's that? That's not nice, is it? I think that's supposed to be the cosine of 45. I'm just going to pretend that. The cosine of 45 is root 2 over 2, or 1 over root 2. So I end up with negative root 2 over 2, or I might end up with negative 1 over root 2. Amazing. Guys, so you've got a few others here if you want to try them now. We're going to go over these in class when we see you next. Yay! Get it? Sine of pi over 2 is 1. It's really good, isn't it? Math jokes. You guys, so in this lesson we did a lot of review that you've done with AAF and some new definitions to evaluate trig functions of any angle, and just keep in mind that we want to be speedy with our trig, right? Okay. We'll see you guys next time.